Hey guys, that might get me back here with another video, guys, and today we'll be doing something interesting, and that's going to go ahead and be showing you guys how to count in binary. Now, I know you're watching this video like, what the heck? Why did you upload a video about this? Well, first off, because this is related to coding, it's related to computers. Obviously, everybody wants someone else to make a Madden game other than EA. So, for people who are interested in coding, interested in binary, interested in this kind of stuff, it's very easy to learn, very easy and simple. So I want to show you guys in case anyone sees this video, gets interested in coding, and maybe you can make the best Madden game, right? Nonetheless, though, this is binary and how to count in it. Now, I am currently taking this in school, in college. Obviously, I'm doing computer programming class, and my teacher did not do a good job explaining this to me, and I had to teach myself, so we're just going to go ahead and teach you guys and kind of relate the knowledge, right? So let's go and talk about binary. Binary is the literally just zeros and ones. So pretty much the idea is these are the only two numbers in binary. No other numbers exist. 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 technically, but the other numbers do not exist in binary. So only zeros and ones. Now, how you count in binary is, for example, if we're going to count on an 8-bit field, we have 4 zeros, another 4 zeros. So obviously, basic knowledge is just basically looking at this. You could probably guess that this right here would represent 0, right? If nothing is turned on, if nothing is anything, it's just zeros, this answer would equal 0, right? Now, the way you look at this is you have ones and zeros. Now, you got to think about this like light switches, okay? If a 1, it is turned on, okay? So if you have a light switch, right? And you have one light switch right now, and you can either turn it on or off. You have two different options. You either turn it on, you turn it off. If you turn it off, it's a 0. You turn it on, it's a 1. With that, you turning it on, that means you're using that variable, or you're using that spot, right? So let's go ahead and take a look at what these placeholders actually represent. So if we go ahead and push these out a little bit just to make them a little bit easier, because each of these different zeros does have a different place. Now, if you ever done anything when it comes to math, you know that, well, when you get past the decimal point, you have the 100th place, the 1000th place, you know what I'm saying, right? You have that different places after. And that's the same thing with this. So if we start off all the way to the right, so we start off with this first 0. This first 0 will be the ones place. The ones place. So meaning, if you would like to go ahead and get 1, you would have to go ahead and just copy and paste right there and change this to a 1. And now you have written number 1 in binary. Because you can see the ones place is flipped on, every other place is flipped off. Therefore, that is 1. The second place we have here is going to go ahead and be the 2. And what these are, and if you could probably guess this if you're just like kind of focusing here, is the fact that these are all the powers of 2, right? So we have 2, 4. You could probably guess the next one, which is going to be 8. And then we have 16. 16, bam, 8 times 2. Then we have 32. Well, if I could type right. 64. And finally, this one's actually a little bit confusing because it's not going to be exactly what this should be, but it is 128. Now, this is the powers of 2. Of course, you can see right here, 1, 2, 4, 8, 16, 32, 64, and negative 128. Now, the reason why this is negative is that this first term we have right here, this in this 8-bit binary code, this is your signed term, meaning it is either going to tell if it's negative or positive. So if this is a 1, most likely this could be a negative number. If this is a 0, it's most likely going to be a positive. Well, it's going to be a positive if it's 0. So, for example, if we're going to go ahead and do some basic counting right here, again, we are in the 8-bit field. But, of course, we do not need to be in the 8-bit field if we are counting, just smaller numbers. Let's say we're counting to 10, right? So if we're counting to 10, and I'm going to go ahead and push this out a little bit so you guys can see a little bit better, demonstration of what this is looking like. So you can see right here, this is how the basic layout of an 8-bit field and how you would count. So, for example, if we're going to take away this, we do not need 8 bits. If we all do an 8-bit field, we will be doing with all 8 of the bits, right? But realistically, if we're just counting binary, just normal counting, what we want to do is say, for example, let's use 4 bits for this one, okay? We have 3 zeros. Now, how are we going to get the number 2? We already got the number 1. We already understand that, but how do we get the number 2? Well, what we want to do is we want to look at this at the very top, and we want to see, okay, what do we need to do to get the number 2? Well, first off, we know what we need to do is, if we're just looking at this, just a 4-bit field, not the 8-bit field, we need to go ahead and turn on the 3rd 0 and then turn off the 4th 0, meaning, there you go, that's 2. Because what we did here is we turned on the 2 indicator. So right here, this is the second one, this is the number 2, and then 0. So right here, what we're saying is that number 2 is turned on, so therefore this is the second. So if we want to go ahead and turn on the 3rd, meaning we want to count to 3, we would just go ahead and do the exact same premise, except this time we need to do a little bit of math. Not really much, but a little bit of math. What we need to do is take the second term and plus the first term to get 3. Because these are indicators of 2, and these are the 2s, 3s, 3, 5, 7, 9 are not actually on, you can't just go ahead and say, oh, I want 3, so where is 3 on this number chart? It's not on the number chart because that is not how you do it. You have to go ahead and do some addition and find out, okay, 2 plus 1 equals 3. I want 3, so therefore it is 0011. Next one we have here is we're going to go ahead and count to 4. Well, this one's kind of easy because we already have 4 on the number chart. So all we have to do is go ahead and just put the 1 there. We don't want any other things turned on because we do not want to go ahead and use any other numbers, just the number 4. Hopefully this is making sense to you guys, and hopefully you guys are understanding this. It's actually really easy premise. Again, when I learned this in my class, my teacher, I don't want to say he did a bad job, but I just personally could not learn from him. So I'm going to go ahead and show you guys this in case anyone's interested, in case you guys are going to go to college someday and you're like, what should I do? Does this interest you? Definitely tell me down below. Next thing we have here, so again, we have 4. In order to get 5, we have to go ahead and just turn on the second indicator for the 4. We have to put the 0 where the 2 places because we don't want 2, but we do want a 1. So we have to go ahead and put the 1 right there. Now, if you guys are, ever wondering, like, for example, if you guys have, if you guys are like, hey, I don't want to do this myself, you can use a calculator, obviously. We go ahead and go here, we go to the left hand side, we go to programmer, you can see that the calculator is right here. And if you want to go ahead and check this out or double check my work, you can see. Let me go ahead and make this a little bit smaller for you guys. Alright, so for example, if we're going to go ahead and do this real fast, 1, you can see right here would be, obviously that's 2, but yeah, that'd be 1. Number 2 would be exactly what I have right here, number 2. Number 3 would go ahead and be 0011, which is right here. Number 4 would be 0100, and number 5 would be 0101. So if you guys are, like personally speaking, you're like, oh, I don't 100%, know this, or I don't 100% know exactly what I'm doing here. You can always double check yourself with a calculator if you're trying to do this at home. If you're trying to do this like teach yourself, you can always do that with a calculator. So where we left off was, we left off with 4 plus 1 is 5. So if we're going to 6, we just simply do bam, bam. And of course, we turned on the 4 indicator and the 2 indicator in order to get that. Now, if we are going into an 8-bit field, now again, I kind of made it simplified, or not simplified, but I made it a little bit less by not adding the extra zeros. But it's the same concept, even if you had the extra zeros. Because in reality, it doesn't matter if you add the extra zeros because they don't add anything to them. They are, nothing's being turned on when you have these extra zeros. So let's go ahead and show you real fast. What did I do here? This was 0. Okay. There we go. Okay, that was, I think, yeah, that's 6. Okay. So let's go on to the next one. So let's go ahead and get a little bit higher number. Obviously, right now we just counted to, actually, you know what? Let's just finish this counting, actually. So this was 6. 7 would, of course, be, I'm just going to add the extra zeros for right now, but the 7 would be literally 0, 1, 1, 1, because we're adding 4 plus 2 plus 1 is 7. 8 would be all zeros, 1 and all zeros, because of course we already have an 8 indicator. 9 would be literally just 1, 0, 0, 1. And finally 10 would of course be if we add all the zeros here. And the reason why I'm adding all the zeros, you're going to see in a second. But we have all zeros and we have a 1, we have a 0, we have a 1, we have a 0. So that is 10. So that is counting to 10 in base and binary. And real fast, let me go ahead and just add this number 1 in here just so you guys, don't get confused here. We do have that as being 1. And of course, we do have, if you want to even go farther, we have 0 right there. So this is counting to 10 in base binary. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, sorry, 0, 1, 2, 3, 4, 5, 6, 7, 8. Wait, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. Not to confuse my own self by trying to count there. Okay, so that is counting to literally basic counting of 0 to 10. You guys know that everybody watching this video knows how to count 1 to 10, right? Or 0 to 10. Obviously, this isn't binary. This is not, same concept. Now, honestly, everyone watching this video at this point, after watching this part, you should be able to count to 127 in binary. Because honestly, all it is counting to 127 is exactly what we've been doing, but just continuing it. So, for example, if we want to go ahead and count to 11, same concept. Now, of course, real fast, we have, let me go 0, 4 zeros, and then counting to 11, we just simply go 1, 0, 1, 1, which of course would go ahead and be 11. Now, next one we have here, I want to go ahead and do a little bit higher of a number just because of the fact that obviously counting these smaller numbers is easy. You're only using the right side of the column, right? You're only using the right 4 numbers. Let's go ahead and use the left side. So if we're going to go ahead and, for example, use the number 40. Let's go with 40. Let's go with 40 actually. 40, just keep it simple, right? 40 would literally just be, we want to go ahead and turn on 0. We don't want a negative. This is a positive number. We do not want the 64, but we do want the 32. So we want to turn on the 32. We're going to turn off the 16. We're going to go ahead and turn on the 8. We're going to turn everything off, and that is 40, just like that, right? Now, again, if you're trying to go from, let's say you're trying to do negative, let's do negative 10, right? You're trying to do negative 10. Well, first off, you do have to do a little bit of math because you're starting off with 128. So if you're trying to do negative 10, you're going to have to start off with a negative number, right? So we're going to start off with a 1. Now we have negative 128 in our reservoir. First off, we're going to subtract 64 because obviously that's the first thing we're going to do here. We're going to take 64 out. So obviously we have negative 128. We're going to subtract 64. So now we are at negative 64. We're going to subtract 32 because we can subtract it again and still be in our, our range of number we need because we want negative 10. So now, next thing we got to do is we have to decide or not if we're going to take away 16. Now, personally speaking, we can take away 16 because, of course, that is still going to keep us above our number. Now, negative 16, we are 5 away. So, first off, we cannot take 8 away, so we're going to put a 0 right there. Can we take 4 away to get negative 10? We can. Can we take 2 away to get negative 10? We can. And that actually would put us at our number. So this is how you would write negative 10 in binary. So of course, once you go ahead and get into the positive numbers and get to the negative numbers, you do have the 2's complements. You have the 1's complements. If you guys are interested in learning more about this, definitely hit that like and subscribe button, guys. If you want to see more and you want to learn more about binary code, if you want to learn more about learning binary, tell me down below and I'll definitely feel free to teach you guys. Because I know a lot of people, when I went to college, I'm going for computers, a lot of people are interested. So I definitely want to see if you guys are interested in learning some knowledge about computers, about coding, about, binary code, about different bases. Like, if you guys are interested, we'll talk about different bases and how to count in 16s, hexadecimal, octal. Obviously, you guys, everyone watching this video knows how to count in decimal. Decimal is just literally the basic counting system. We'll talk about all that in a separate video if you guys are interested, but this is just the, kind of basics of binary and how to count in binary. So thank you guys for watching. If you enjoyed this video, make sure to like and subscribe button. See you guys next one. Peace out.